How we doing, guys? Welcome back to videos again here. We're looking at differential calculus, but because there's a new textbook now, I'm not going to be putting pages and things up anymore. So text and test 7 if you're in the old class, and from now on it'll be I think text and tests 5. I'll put the page numbers up from now on underneath the video. But we're looking at a concept called average values here. We've met something similar before. If you have the slope of a line, this straight line here has a slope 1/2 or a slope of 1/2 or 0.5. Well, what does that mean? We say that's the rate at which y changes with respect to x. Okay, so if y, for example, had units of euros, then this is changing at half a euro per, let's suppose this has units of minutes. So half a euro per minute might be a phone, the price of a phone bill, or the rate at which you're charged. If this was changing at kilograms per, let's say per meter, okay, you might say if you were doing a survey of heights, that people are getting on average half a kilogram heavier per meter of height, or well, that doesn't make much sense, but per centimeter maybe. If this had units of litres per minute, you often see questions about a tank of water filling up, the rate at which would be 0.5 litres per minute. So it's how y changes with respect to x is what the slope can represent. So slope may be thought of as a rate of change. And you're going to hear that phrase an awful lot in this chapter and future chapters on calculus. It's a rate of change of y with respect to x. Okay, so just with respect to. Now, if you have a curve, so this line here is x squared minus 1. And you want to talk, well, at what rate is that function changing? You've got a problem because it's changing at different rates at different points. So for the moment, we're going to talk about a concept called the average value between 2 points. So for example, between x equals 0 here and x equals 1, okay, that's x equals 0, is this point here is x equals 0, and this point here is x equals 1. The average value is the slope of the line between the 2 points. Okay, so the average value here, rise over run, is 1. Whereas between x equals 1 and x equals 2, this point up here, if you plug 2 in here, you get 4. 2 squared is 4, take away 1 is 3, so that's 2, 3 up there. But between x equals 1 and x equals 2, well, that line has a slope 3 over 1. So now this average value between those 2 points is 3. So the average value between 2 points will change depending on what 2 points you choose. But it's always the slope of a line. Okay, and you can see here you've got an average value which is negative on the far side. I may as well just do all the points here. Between minus 1 and 1, your average value is minus 1. Between minus 1 and minus 2, your average value is minus 3. And you're allowed to take the average value between, say, minus 2 and 0. Obviously, well, maybe not obviously, I'll talk about this again later. The average value between minus 3 and 0 is going to be minus 4 over 2, which is minus 2. And now I've just made a mess of that diagram, but that's okay. The slope is a rate of change. The average value is also a rate of change. It's just a rate of change between 2 points, and it's an average rate of change. Okay, because it has to be an average value. So looking at some of the questions in the textbook here, if we start with question 2, find the average rate of change of the function depicted in the graph shown for the interval minus 2 and 5. So between the x values of minus 2 and 5, they want the average value of this. It looks like a logarithmic function. Here's the function here. We can show you what we're trying to find here easily enough. That point there is 520. It's the slope of this line here. That's what they've asked us to find. The average value between these 2 points is the slope between these 2 points. Okay, so you say, well, rise over run here. From 20 to 4 is 16 over 5 to minus 2 is 7. So the average value, the slope, is 16 over 7. Alternatively, you can say slope is y2 minus y1 over x2 minus x1. So you label your points. That's x1, x2. That's y1. X1, y1, excuse me, x2, y2. Okay, so this is going to come out as 20 take away 4 divided by 5 take away negative 2, which again gives us 16 over 7. Okay, question 3 asks us find the average rate of change of y with respect to x from point A to point B for each of the following graphs. Okay, so we've got two graphs here, but really we don't need the graphs. If we have the 2 points, all we're being asked to find here is a slope. Okay, so I'm going to work with that now, and I'm going to say for question 3, part 1, I know that my first point A, I'm going to call x1, y1, and my second point B, I'm going to call x2, y2, and that the slope then between them is going to be 5 take away 30 divided by 2 take away negative 5. And that gives me negative 25 over 7, or what's that, 3 and 4/7, minus 3 and 4/7, if you like. Down here, again, this one looks to be an exponential curve of some kind. It doesn't really matter. Average value between those 2 points is the slope. So again, x1, y1, x2, y2, and I come along here and I say 15 take away 3 over 3 take away 0. That's 12 over 3, which is 4. Okay, so the average value there is 4. The average value up here, by the way, is negative. And if you look at the graph, you can see that going from A to B, you're going down. So you'd expect a negative average value. Last question, question 6. A cube has edge of length x centimeters. Find an expression for the surface area of the cube and the average rate at which the surface area changes with respect to x as x increases from 2 to 5 centimeters. Okay, so x is the edge of the cube here. Okay, so this length here is x, as is this length, as is this length here. Okay, so this is what you're looking at. A cube where each side is x. So each face on the cube is x squared, and there are 6 faces in a cube. So the surface area expression is going to be 6x squared, which is a quadratic expression. When the length of the side is 2, the surface area is going to be 6 times 2 squared, which is 6 times 4 is 24 centimeters squared. But now we can say, well, we've got this point. If x is 2, y is 24. Okay, because that's just a quadratic curve, and this point here, 224, is a point on that curve. Same thing down here. When x is 5, we'll say 6 times 5 squared, which is 625s, or 150. And again, we get this point 5, 150. Okay, so for our cube, we can say the average value is going to be the slope, average value, which is going to be questions. It's going to be y2. So let's label this x1, y1, x2, y2, and it's going to be 150 take away 24, y2 minus y1 over x2 minus x1, and that is going to be 150 take away 24 is 126 divided by 3, which is 42. Units here, the rise is in centimeters squared and the run is in centimeters. So centimeters squared per centimeter, what that means is on average between this length changing from 2 centimeters to 5 centimeters, the average change in area was 42 centimeters squared for every centimeter that the length got longer. But that is an average rate of change between these 2 points of 2 and 5. You would have a different rate of change at between the lengths of different lengths. Excuse me. Now for homework, our classwork tomorrow. please finish this exercise. Okay, which I'll reference in the video title because I might be changing it with the textbooks again. Okay, see you tomorrow, guys. Bye-bye.